Last class, we have taught the topic about symmetry, and we have to say that when you are going to be rotating the object or making a line, you are getting the exact image on the other side. You are getting the reflection of the object, so that is known as the line of reflection. If after rotating the object, you are getting the same image or same object or the original shape. So you have to say that that is a rotational symmetry. So in the last class, we have discussed about the line of symmetry as well as we have to discuss about the rotational symmetry as well. Now, in today's class, we have to be go for to discuss about the planes of symmetry. What is the lecture number today?
63.
Go to it. All right. So we have to talk about a plane of symmetry. Okay, basically, if we are going to talk about a plane is just basically a flat shape. Okay, for example, it just look like this. This is going to be a plane. A plane can be a rectangle, it can be a square, or it can be a circle, or it can be any other shape. It can be a triangle. All right, but the plane is going to be. You can explain the plane. The term plane is a flat surface that uh, can be any 2D shape. All right. Okay. If we are going to be talk about the plane of symmetry, so the plane of symmetry is plane of symmetry. Obviously, if we are going to be taking a plane of symmetry, that must be in the 3D shapes. All right. The plane of symmetry is a plane that splits a 3D shape into two identical halves. All right. It is just in simple word. It is just divide the 3D shape into two equal parts. All right. So that is the plane of symmetry. For example, if I have to talk about the different shapes that we need to be discussed here, the first one is the cube. The first one is a
Yes.
cube shape. So let's say have to take a cube here from here. Cube shape. Right. So here we have the cube. Okay, look at here. If in this one, I'm just going to be, it's a cube, obviously the arc lengths are going to be equal. If I'm going to make a plane here, from here like this way. Can I take the plane here? Just at the mid of the cuboid. So obviously it is a plane. This means that this plane divides this shape into two identical shapes, means the two equal shapes. The upper part and the lower part. Means the upper part obviously it become a cuboid and the lower part is also a cuboid and they are exactly same. So means this plane divides this shape into two equal parts. So means this is a plane of symmetry. It is clear?
Yes,
Yes,
sir.
sir.
In the same way, if I'm going to draw it at the mid of here, we are getting one more plane because it is going to be divided into two equal parts as well. In the same way, if I'm going to be draw a line here, it is going to be divided into two equal parts. Yes, how many symmetries are there?
Yes, sir.
How many planes of symmetry are there?
9.
Three.
How many?
9.
I just make three here.
Yes, yes.
Yeah, the
Yeah,
totals are nine, I know
yeah.
that. But
3
here we have to
to
just
sir,
draw three.
and 6 to diagnose.
Okay, I'm going to be take this shape again, and let's we have to talk about diagonals now. So in diagonals, so we are going to be get the plane like this way. Look at here, it is dividing into two equal parts as well.
Yes, sir.
In the same way, from here, it is going to be divided into equal parts as well. Let's have to change the color so that makes it distinguish. Yes, any other one? Yes, from here.
Yes,
It
sir.
is, any any plane of symmetry is left in diagonal? One.
No, sir.
Yes, that is from here. Let's have to change the color.
Yes.
Uh, Look at here. It is going to be divided into two equal parts as well, right? So how many they
Yes, sir.
are?
6.
One, two, three, four, five, six. So the total numbers of lines of symmetry are going to be a plane of symmetry are there. We have so a cube has 9 planes of symmetry. Is it clear?
Yes, sir.
Yes. Anyone have a question over here?
No.
No, sir.
Okay. It is a good shape on the internet, so it is going to be more clear that how you can make the different lines of symmetry. Look at here, one is the half, and this half. You have to make three halves. Then you have to make into the diagonal this one. Oh, I did not make it like this way. One and two diagonals as well. And then we have to one, two, three, like this way as well. So we are getting total 9 lines of planes of symmetry in a cube. Okay, now the next shape we have a cuboid. So let's see, I have to take a cuboid shape. Okay, in cuboid, obviously we know that the length, width, and the height are not going to be equal. So we have different, the diagonals are not going to be same. So that's why we are just going to be get three lines of symmetry, planes of symmetry. The one is at the middle. It is clear because it is going to be divide the cuboid in the upper half and the lower half. If I'm going to be draw the lines of symmetry, plane of symmetry here, it is going to be divide the cuboid into the left half and the right half. In the same way, if I'm going to be draw another plane like this, it is going to be divide the cuboid into the front half and the back half, and they are exactly same. They are identicals, right? They are congruent figures. Is it clear? So, how many planes of symmetry are there? We have
Three.
three planes of symmetry in a cuboid. Okay. After that, we have to be discuss about a pyramid, and we are just going to be discuss about a pyramid with a square base. Right? The thing that
Yes,
is in
sir.
our syllabus, that is only a pyramid with square base. So let's have to take a pyramid from here. Okay, now it is a pyramid. Let's say it is going to be a square base. All right. If it is a square base, obviously this point is going to be must be at the center of the square. All right. If it is a
Yeah.
square base, this point must be at the center of the square. So from here we have to make the symmetry. The first one is just going to be like this. Look at here. This triangular plane divides the pyramid into two equal halves. Clear?
Yes,
The
Yes,
yes,
sir.
left half and the right half. And if I'm going to make another one, it is going to be divided into the front half and the back half. And there is one more. Now here I'm going to be taking the pyramid, the diagonals. The diagonal means in the front of you, you have a first diagonal half and the back diagonal half. In the same way, you have to make it on the other one. You are going to be get here this half and this half because these planes are divided a pyramid into two equal halves. Is it clear? So look at here how many planes are going to be here.
Four.
four.
We have four planes of symmetry here. Clear?
Yes,
Yes.
sir.
Pyramid. I have to write.
Assalamu alaikum, sir.
Wa alaikum assalam. Yes, how are you?
Fine, sir. How are you?
Alhamdulillah. Okay. If we are going to be talk about cylinder, as we talk about cylinder shape, let's have to take the cylinder from here. Now look at here, we have a cylinder here. Okay, we can different planes of symmetry here. We can make a rectangle here, but if you are going to be making a circle, not able to make it a good one, but I will try my best to make it. I can make a circle here. You can make a circle here, right?
Yes, sir.
Yes.
Yes. And first of all, we have to make a at the mid one, right?
Yes, sir.
Yes, sir.
In the same way, we have to make it in this way. And we know that a circle has infinite lines of symmetry, right?
Yes,
Yes.
sir.
You are making a line. Okay, one is going to be here, but the others are you are going to be taken here. It is going to be here or a little bit. Obviously, if you have to are able to make infinite lines of symmetry here, so in the same way, you are able to make infinite planes of symmetry as well, like this. You have to make as much as you can, right? So this means that in a cylinder we have infinite planes of symmetry. Yes, it is clear.
Yes, sir.
Yes, sir.
Okay. After we have after the planes of symmetry, we have the rotational symmetry of 3D shapes. Obviously, we have 2D shapes, but we have 3D shapes as well, in which we have to be look for the axis. Means you have on any axis, you are going to be rotated the figure into 360 degree. So you are going to be get
Same shape.
a rotational symmetry. So I do not have more shapes, but I have one shape. But after that, it is going to be very clear that how to make a symmetry. Um, let's have to make it by myself. Okay. Just 1 minute. Mhm. All right. So if I'm going to be draw a line here, it just passes from a center. All right. So if you are going to be rotated, it is going to be come into the original shape of the 3 times, right? because it's an equilateral triangle. Okay, it must be equilateral triangle. And here, if this face is going to be, when you have to rotate it, it is going to be here, and means one times. When you are going to be again rotate, this face is going to be here. Again rotate, it is going to be back into the initial condition. So you are going to be see the original shape three times. So this means that it has three rotational symmetry, or rotational symmetry order three. Order of rotational symmetry will be equal to 3. Yes, I know it is clear.
Yes.
Yes, sir.
Okay, after that we have to be make a square base pyramid as well. You have to make a pyramid that must be a square base. Let's I have to draw it here. Let's say this is a pyramid. All right. So this is going to be the line. Yes, this is the line on which you have to be rotate it. All right, in this direction. If you have to be rotated, how many times you are going to be see the original shape?
Three
Four.
times. Four,
Four
four.
Four.
times.
4 times, because we have four phases, so you are getting 4 times. So this means that we have a rotational symmetry order will be equal to
4.
4, right?
Yes.
And the last one is again the cylinder. Let's have to take the cylinder shape down. Okay, I'm going to draw a line of axis in which he is going to be rotated. So from here it is passes from, and from here it is passes from. Here, this is center. So if you are going to be rotated up to 360 degree, so in finite times you are going to be see the shape. Clear? The
Yes.
same shape you
Yes,
are going
sir.
to create. This means that you have infinite
Rational symmetry.
finite rotational symmetry. And if we are going to be talk about cone, C-O-N-E, cone. Okay. Now it's a cone here. We have to talk about the symmetry of this one. Look at here, same as if you are going to be rotated. So every time you are going to be getting the same shape. This means that the rotational symmetry of cone
Infinite.
is also
Infinite.
Right.
times infinite rotational order of rotational symmetry. That is infinite. Yes, it is clear.
Yes, sir.
Yes,
Yes.
sir.
Yes.
Okay. In the last class, we have to be discuss about the little bit about. I have sent you the topical worksheet, right?
Yes.
All right. So let's we have to open it here and do some questions. Just a minute. All right. Just a minute. Just open it here. Yeah. Okay. We have done the first and second part. Okay. Now let's see have to discuss about the plane symmetry because we in the last class we did not about discuss anything about plane symmetry. Yes. Look at the shape. It is a cuboid. Yes. How many plane symmetry in it? In which? Yes, Tahur.
3 planes of symmetry.
We have. He says that you have to sketch one of plane symmetry. So let's have to sketch this one because it is just dividing into the upper half and the lower half. You can draw this one as well because we just discussed about three symmetries. In the next one, write down order of rotational symmetries of equilateral triangular prism about the axis shown. We just discussed it. Yes, how many times? If you are going to rotate it, how many times you are going to see the original shape?
3.
3 times.
3.
The order of rotation symmetry is
3.
we have done the first few questions, so we have to start from any of the ones. Yeah, let's we have to start from here. Question number 8. Yes, we have to be shared one square in each. You are getting the one line of symmetry.
The corner one.
The corner one. No, no, no.
The top right corner.
The
Yes, sir.
top
Same
right corner.
corner.
This one.
Yeah.
So after drawing it, you are getting a line of symmetry, a vertical line or a horizontal line.
Vertical.
A vertical.
You are getting
Vertical.
this line of symmetry here. All right, here you need a rotational symmetry of order 2. Yes, Hanana.
The bottom right corner.
Right corner top,
No, the bottom.
the bottom one.
Yeah.
This one. Okay, let's see how to check. I'm going to be rotated. Yes, it is exactly same.
Yeah.
Yes, sir.
Then we have to go back. Again, it is exactly same.
Same.
So means we have to be share this one. Okay. When you are doing it in the exam, you have to use a tracing paper or you have to literally rotate your paper, okay? If you don't have. Okay,
Okay.
now this part, the pyramid below has a rectangular base. Oh, we have a rectangular base. The vertex of a pyramid is vertically above on the center. Okay, so then this information is more information is given. It is just vertically above on the center of the base. So write down the number of plane symmetry of the pyramid you have. So this is the line on which he is going to be cross it. This is the center. Yes, how many times you are going to be see the original shape?
2 times.
Yes. If you have to be, let's say you have to start from here. So when you are going to be rotated it, so when it this face on the back and the back face on the front, you are going to see the original shape, and then after 360-degree. All right. And if you are
Okay.
starting from here side, the same as when this face is going to be on the opposite side, it is one times, and it is going to be back, it is another time. So means we have the rotational symmetry is
Okay.
going to be 2. But the center must be at the center of the base. Okay, it is
Okay.
only then possible if it is uh, if this point or this line is not above the center of the base. So obviously this thing is not possible. We have zero rotational symmetry then. All right, question number 9. We have to write down the number of lines of symmetry for the diagram. Yes, how many lines of symmetry we have? Yes, Tahur.
One.
Just one? Yes, Hannah.
Sir, there is 0.
Let's see how to check. We have just one. The image of this part is not going to be here,
Yeah.
right?
Yes, sir.
This means that it is not a rotational symmetry. It is not a line of symmetry here. And in rectangle, we don't have, we just have two lines of symmetry, the vertical and horizontal line.
Horizontal.
And obviously, we don't have horizontal because this box is not going to be here. Yes, so we have zero line of
0.
symmetry. Okay, now we have rotational symmetry. So we are going to be literally rotated and check them. Let's see how to rotate. 90 degree not equal. 180 degree it is going to be equal. Not equal. Equal. So the order of rotation symmetry is
2.
2.
2.
2. All right. The graph shows a cuboid which has no square faces. Okay. This condition is given. It does not have any square face. Draw one of the plane of symmetry of a cuboid. Yes. So we can make it here.
In the middle.
Yeah, in the middle. You can make. Sorry. We can make it like this way as well, right? But that's okay. We just have to draw one of them. Okay. This cuboid has a square cross-sectional. Write down the number of planes of symmetry. Write down the number of planes of symmetry. Yes, it is a square. Yes. How many we have?
Sir, 9.
5.
Okay,
Is there
5.
5?
How we have fives? We need to be draw it as well. The one,
In the
right?
middle. Yeah.
This is the one.
Yeah.
And then the one going across.
2.
Wait. And then another going diagonally.
No, obviously, we cannot make a diagonally like this.
Yeah.
Yes, sir. It's 2.
Right. Just a minute. I will take this one here. I'm not sure. This is not the line of symmetry. There is any other one. Because it is a square, so you can make like this, not like
Oh,
that way, and you can
Yes.
make way. All right.
yeah.
The 2 is going to be diagonal and 3 are going to be
Uh,
vertical. All right.
yeah.
Means like this way, and the diagonal way that we have make it 3 here. Where are they? These 3. 1, 2, and 3. These are going to be the 3 here. 1, 2, and 3. Like this. And the 2 are diagonals. So how many we have?
5.
5.
5.
All right. I will have to draw the rest of them, but obviously it is going to mix up. It is going to be difficult to understand, but I'm going to try it. The 1 is going to be here. It is dividing into the upper half and lower half. It is dividing into the upper one and the first one and the back one, and we have this one. So we have total number of symmetries are 5 here. Clear?
Yes,
Yes.
sir.
All right. Now we have this cuboid has a rectangular cross section. Okay. The axis shown passes through the center of the 2 opposite faces. Write down the order of rotational symmetry of cuboid about this axis. Yes, how many?
2.
Obviously, when this face is at the front, when you have to be rotated, it is going to be at the back after 180-degree rotation once, and then 180 again rotation, it will be back into the previous position. So you are going to get 2
2.
times
2.
the 360 degrees. So we have the order of rotation symmetry is 2. We have done this question. Okay. From the above word, write down the letters which have exactly 2 lines of symmetry. Yes, which are the letters you have exactly 2 lines of symmetry? Yes, Sanana.
I.
I. In I, obviously, this is the one line of symmetry, and this is
The
another
other.
line of symmetry. There is any other one?
No, sir.
No,
No.
Have
there's
M,
oh,
but in M we have
there's
more lines of symmetry, right?
yeah. Wait, no.
We have O here. So in
Yeah,
O we have infinite, but he says that you just have to find out in which exactly
exactly.
two. So
Yeah,
that means that there is only
I.
I. Okay, rotational symmetry of order 2. Rotational symmetry of order 2. Yes, yes, Harana.
I and N.
Yes, Fatma, Safa, Rabia, are you here today?
Yes, sir.
All right.
Yes,
Yeah.
sir.
Okay, yes, rotational symmetry are
I and N.
Yes,
Yeah,
sir.
I and N.
I and N.
N.
Yes, after 180 degree it is going to be upside down, and after 180 degree it is going to be exactly same. You can rotate it. For example, if you have N, let's see how to rotate it. It is 1 and 2. What about M? It is not?
No.
Mm.
All right. All right, so yes, let's do the last one. The diagram shows a cuboid. How many planes of symmetry does this cuboid have? We just discussed the basic shape. Yes, how many we have?
5.
No, it's not a square. One is not
3.
a square.
3.
Yes, we have 3. So this is the one plane, second plane. Where is the third plane? Yeah, this one. So first off and last off. These are the planes. So we have three planes of symmetry. Does this divide have? Write down the order of symmetry for the following diagram. All right, let's see how to rotate it and check that if there is any one, right? Two,
Three, sir.
three, and four. So here
Four,
we
sir.
have
Four.
four rotational symmetry. Add one line to the diagram so that it has two lines of symmetry. Yes, here I have to draw a line. Obviously, this one. Yes.
Yeah, that.
And add two lines. Okay. Now this is an interesting one. Yes, we have to be add two lines. Yes, banana.
Um, the line that's going up, we would draw another line down. That same line on both sides.
Sir, we'll make it like a pentagon.
And two.
Yes, sir.
So I say we should make it with like an eye shape by completing the other side.
We have to make this line or not?
We can,
This one
and
and
then
this one, I think.
yeah, that could go.
So look at here. If you have to rotate it, you are getting two lines of symmetry. You
Yeah,
are talking about any other shape?
yeah, like making an eye.
Okay. 1 minute. Okay, one possibility that I have to draw it here, that is this one. Yes, Rana, you have to tell me where I have to draw a line
On the bottom of each line.
like this,
Yeah, with the same length, but
like this.
yeah, yeah.
Uh, let's see how to rotate it. Yeah, if we have to make it exactly the same length, yeah.
Yeah.
We, but obviously in my mind, this is this one. Okay, if you have to rotate it, you are going to be getting the same.
Accurate result.
Yes, everyone, it is clear. We just have to complete
Yes, sir.
one.
Yes,
Now
sir.
we have done the whole concept about symmetry, in which the plane symmetry, rotational symmetry, lines of symmetry, and all of these stuff. Here you have a complete notes about the symmetry that you have. Any questions?
No.
No, sir.
No.
No,
If you
sir.
have any questions from